Hi, this is Tom, and in this lesson we're going to learn about the inverse function. And I'm going to begin with a bit of a metaphor to help us understand. We're going to take a look at the Starship Enterprise. For those of you that watch Star Trek, this is their big spaceship, something like this. And it's got a nice big body here on it as it travels through space. It's got these little wings. I'm not exactly sure what they are. They're cool. Okay, so here's the Starship Enterprise, and we're going to abbreviate it as SE. Now, the Starship Enterprise travels through space, and it has the ability to go visit other planets. And so we'll just call this P for planet. Now, in in the Starship movies, or sorry, in the Star Trek movies, regularly what they do is they need to send a person down to the planet. Or they can send people. So they get the person down to the planet using the teleporter. So this is where they send them from the Starship Enterprise to the planet. And so I'm going to keep track of this as where we begin and then where we end. So initially here, I begin on the Starship Enterprise and I end on the planet. Now that I'm here on the planet and that I've discovered that it's hostile and no one there really wants me here, I need to get beamed back up. And this is where they would say, beam me up, Scotty. So when they do that now, let's think about what happens. Now they're starting on the planet and they're ending on the Starship Enterprise. Believe it or not, their teleporter that beams them out and beams them back, this is an example of a function because it takes something that you know and puts it where you want it, then it takes it from where it is and brings it right back to where it starts. So I'm going to call the process of going to the planet, this is our function, the beaming process. The beaming back process is the reverse of the function, the reverse of the function. And the reverse of the function is called the inverse function. And then to be even more consistent, if I have a function that takes me from the Starship Enterprise to the planet, instead of calling it function, we could just call it f, like we have been. And for the function that gets me back, the inverse function, we use this notation. We call it f raised to the -1, f. And this is actually read as inverse, or let me undo that. It's read as the inverse of f. The inverse of f. Okay, with that, here's what we can do. Let's take a look at a simple function and its inverse. So I'm going to give you the function f of x equals 2x minus 1. Now you don't know how to find an inverse yet, but I'm going to give you the inverse so you can see what happens mathematically. So the inverse function says you take x, you add 1, and then you divide the result by 2. So let's try this. Say we start with the value of 3. Then this becomes 2 times 3 minus 1. That's 5. So what I did is the ordered pair was I put in a 3 and I got out a 5. Now, let's say I'm at 5 and I want to get back to 3. Well, I would do that by using the inverse function. Oops. So now I want to take the inverse of 5, and if I've done this correctly, it should give me 3. Well, let's try. This is 5 plus 1 divided by 2. Well, that's 6 over 2, but that's 3. And that's exactly what the inverse function should do. Now I put in the 5 and I returned to the 3 from where I started. Right. Let's do another problem. We're going to come up with a grander example, but what I want you to take from this is that if you have the ordered pair of the function, you already know what the ordered pair of the inverse function is, and that is the switching of the positions. Okay, so with that in mind, let's proceed forward. So suppose I have the point, let's try this. Suppose my function now is f of x equals 2 to the x. I'm going to make a table here, and we're going to try a few things. We're going to use some x values. That's pretty good. Then we're going to find out what their f of x is. Then we're going to write their ordered pair, and then we're going to use this notation. I'll write this. We'll write it this way. Ordered pair. And that's the ordered pair of x, f of x. And then we're going to look at the inverse ordered pair. And this we can do quite easily. Inverse ordered pair. Okay, let's try this. We're going to try 5 values. We're going to try negative 2, actually 6. We'll do negative 1. We'll do 0, 1, 2, and we'll use 3 as well. So I'm going to calculate my f of x now. So this becomes 2 to the negative 2. And this, remember, we flip the 2 to 1/2. We square it to get 1/4. And then 2 to the negative 1, we'll just go down each column. So 2 to the negative 1, I flip the 1/2, so 1/2 to the first power is 1/2. 2 to the 0, we know anything to the 0 is 1. 2 to the first is 2. 2 squared is 4, and 2 cubed is 8. Now, if I write the ordered pair, it goes in this order. Negative 2, comma, 1/4. Then my next one is, we'll go down the column. So then I have negative 1, comma, 1/2. Then I have 0, comma, 1. I have 1, comma, 2. I have 2, comma, 4. And finally I have a 3, comma, 8. Now, if we reflect back on what we just did above, we already know this last column in our table. Because all we have to do is we know that if we have an inverse, we know that if we put in 1/4, we will get out negative 2. We know that if we put in 1/2, we return to negative 1. If we put in a 1, it returns us to 0. If we put in a 2, it returns us to the 1, a 4 to the 2, and finally the 8 to a 3. And that is what the graph of the inverse, or the table for the inverse, looks like. Now I'm going to make a copy of this because I need it, and then we're going to graph this. So let's do this. I'll make a copy, and I'm going to just come down here. We'll put it here for now. Paste. And it's kind of big, so we're going to shrink that down so we have it. That should work. Okay, so here we go. I'm going to do a few things. First of all, let's bring some graph paper into this so we have a nice, good-looking picture. So if I graph this, I'm going to have, let's see, my graph will look something like this. And something like this. Okay, and let's graph it. So I'm going to graph this in 2 parts. We're going to graph f in red, and then we'll graph its inverse in, it's kind of a yellow-orange, but I'm just going to call it orange. All right, here we go. So if I graph, let's start with the reds. My first point is negative 2 Ooh, that's a hard one. Let's come back to the fractional ones. I'm going to start with this lower half here because these are a little easier. And then we'll return to the top two. So that's going to be 0, 1. Then I have 1, 2. Well, here's 1 and here's 2. Then I go to 2, 4. Here's 2, here's 4. So that's going to be right there. My last one is 3, 8. Wow, that's way up there. So 4, here's 5, 6, 7, 8. There's 8. So if I graph this, I would be right there. Okay. Now, let's see, let's go back. We have negative 1, 1/2. So at negative 1, I'm at half. And then my next one is negative 2, I'm at a quarter. So I got to split this tiny little space. Okay. Now I can graph my function f. So let's do that. F looks like this. There. And actually, it keeps getting close. If I continue my f, it gets closer and closer and closer and closer. Now we can graph f inverse. So let's start. I'm going to start here, kind of the same way I did the earlier one there, like with those values. So I have 1, 0 this time. 1, 0, 2, 1, 4, 2. Oh, so 2, 3. Go all the way out to 4, and then I go up to 2. And 8, 3. Oh my, let's see if it'll fit. 4, 5, 6. Here's 7, 8. Up to 3. Goes there. Okay, then let's go back. I have 1/2 negative 1. So here's a half. Go down to negative 1. And then I go to 1/4. And I go all the way down to negative 2. And there, that is my graph of the inverse. Okay? And this inverse function just keeps getting closer and closer and closer to the y-axis. Never quite gets there. So, how do we know if the inverse exists? This is a good question. So let's take a look at that. How do we know? How do we know if a function has an inverse? So here's what we do. We use what's called the horizontal line test. So I'm going to do it this way. We know this. A function has an inverse if it is 1-to-1. There's our new vocabulary, 1-to-1. And a function is 1-to-1, 1-to-1 if a horizontal line, if a horizontal line can only pass through the function once. Pass through the function once. Okay, so let's check. This is called this technique is called. I'm going to go up a little bit. Is called the horizontal line test. Horizontal line test. Okay, so let's take a look. Notice that, let's say I try green here. If I take and dot a green line across the red graph, it only crosses once. If I go up there, it only crosses once. What if I come down here around 2? Well, again, it only crosses once. And even though this bottom part looks like it's flat, it still only crosses once. So because a horizontal line only can pass through once, this function is 1 to 1. Since it's 1 to 1, it has an inverse. And then there's one more question to ask. Well, what's not 1 to 1? Or what wouldn't have an inverse? Well, here's an example. Let's use let's use a different function. G of x. How about if g of x is equal to x squared? And this is a function we've graphed many times. So it has a vertex at 0, 0. I go 1 to the left, and then I go 1 up, and I go over 1. I go up the next odd number of 3. I go over 1, and I could go up 5. Let's see, 1, 2, 3, 4, 5. It takes me way up here. And then I can easily graph the other side. And I'm going to stop there, though, because look at this. You can already see how a parabola, simple parabola, actually doesn't have an inverse. Because if you look closely, if we go back to our green line, notice that here's a horizontal green line, but it crosses one time there, and it crosses one time there. In other words, that one horizontal line crossed more than once, twice in this case. So a parabola is not 1 to 1, does not have an inverse. And that is the idea of the inverse function. It takes you back to where you started. And those are its properties and how we know if a function even has an inverse. Thanks for watching.